Okay, let's do this. This is the third topic for this week's objective, and obviously this is your favorite thing, world modeling situations. Okay, this is actually gonna be quite easy, don't worry. So, in this first example, I have a function, and this function models the brightness, the magnitude of brightness of stars at a time t. And let's suppose we start counting when t equals 0 days. So we're being asked to find during the first 69 days, when will the star's magnitude of brightness be 14? So the first part of my question is asking me, or being specifying me, the interval in which I want to find my answer. So my answer has to be between the first 69 days. That means that my answer should be between 0 and 69. The second part is telling me what do I need to find. I'm being asked to find when, so I'm being asked a time, will the star's magnitude of brightness be 14? So I'm being asked when this thing is gonna be 14. So this means I have to bring my equation and equate it to 14 because the brightness is 14. 2 pi over 69. Now, as by now you should know that because we want to find a value of t, we have to leave first my sin expression alone. So to do that, I'm gonna pass everything that is on my way to the other side in such a way that I have sine of 2 pi over 69 times t equals 14 minus 8 over 11. And if I wanna get rid of my sign, I know that I should apply a sign inverse on both sides of my equation. And this would yield the following expression. And I know what you're saying, Andrea, simplify this. So I'm going to simplify this expression. This would be 6/11. Now, here's the first thing that is different from what we've done so far. Here, my argument was different from just t or just theta. Okay, so here's the thing. When we plug this into the calculator, this is going to give us or in return is going to give us an answer in terms of just a variable theta. Okay, so we have to apply a change of variable. Okay, that means I'm gonna say that a heart equals 2 pi over 69t. So I can rewrite this expression as the sine inverse of 6/11 equals my heart. Okay, so now when I plug this into the calculator, I'm gonna find a solution, and that solution, as always, is going to be my angle of reference, and we're gonna do what we did exactly on objective 1. So first things first, we were working with a sine function, so we have to know where both solutions for this problem lie. So from here, we could see that, from here, we could see that this sign gives me in return a positive number. This is a positive number. This is 6/11. So I should know that I have to verify in where is sign positive. And sign is positive in quadrants 1 and 2. So I know my two solutions are going to live here. That is, one solution is going to be this one, and one solution is going to be this one. And by now, we should know that these two solutions have the exact same reference angles. So one solution is going to be this one, another solution is going to be this one. And both of them have the same reference angle, okay? So I'm going to plug this into the calculator. So my first solution, because I know that if I plug this into the calculator, this is always going to give me the solution that is in the first quadrant. I know that my first solution, heart 1, is going to be, well, the sine inverse of 6/11. And my second solution, that is my blue one, is a half a spin minus a reference angle. So my second solution is half a spin minus my reference angle. Okay? and then we can follow up and find those solutions. But here we have to remember what was my heart. My heart was 2 pi over 69. So I'm going to replace those values. Actually, I'm going to just move this right here and this one right here. Okay? So from here I know that my heart was 2 pi 69t, and that equals, according to what we just found, the sine inverse of 6/11. So if I solve for t, that is for my first solution, this is going to be the sine inverse of 6/11, and this 69 is dividing, so it's going to pass multiplying, and the 2 pi is multiplying, so it passes to the other side dividing. So I should plug this into the calculator and it's going to give me an answer. I'm going to do it right now. So if I plug this into my calculator, this is times 69 over 2 pi. This is 6.33. So this is 6.33. And for this example, we're gonna do, well, for this this solution, this solution is in my interval of possible solutions, so it is correct. Now, for my second solution, we said that it was the solution that was in the second quadrant. Heart equals half a spin minus my reference angle. But again, what is a heart? A heart is 2 pi over 69 times t, and that equals pi minus my reference angle. So I say minus sine of 6/11. So again, if I solve for t, my second solution, I have to multiply everything times 69 and divide everything over 2 pi. So this is going to be my second solution, and I'm going to plug this into a calculator. So sine inverse of 6/11 pi minus my answer, that multiplied by 69, and that divided over 2 pi, that is 28.16. 28.16. So these are my two solutions, and these two solutions are in my interval. Perfect. Next example. Suppose a projectile is fired from a cannon with a velocity v0 and an angle of theta. The horizontal distance r of theta, it travels in meters, is given by the following. So this is an expression, and I'm being asked that if v is this thing, what angle should be used to hit a target on the ground of 148 meters. So I have to substitute the info that is given me. V0, it says that is 56. So I have to substitute the value of V0 there. So this is 56 squared times sine of 2 theta over 9.8. And it says that I'm being asked to find theta. So I know I should solve for theta. And I'm being given a distance. And that is what this equation does. So this is 148 equals esto. So I'm going to start solving. First off, I'm going to pass the 9.8 multiplying, then the 56 square dividing, and then I have this expression. Now, for solve theta, I have to apply the inverse function. So this is sine inverse of 148 times 9.8 over 56 squared equals 2 theta. And I'm going to apply my same methodology. First off, we were talking about sines at the beginning, sine of 2 theta, and if as you can see, this is a positive number. It cannot be negative. Why? Because this is positive times positive over positive. So this is a positive sine. And sine is positive in the first quadrant and in the second quadrant. So these are my two possible solutions. Both of them have the same reference angle. So one solution is going to be this one, and my other solution is going to be this one. But remember, I have a coefficient affecting my variable. So I'm going to apply a change of variable, and I'm going to say hard equals to theta. So this expression can be rewritten as sine inverse of 148 times 9.2 over 56 squared equals hard. So my two possible solutions are my first hard, that is the straight up answer, that is just the solution that is going to be given by the calculator in the first quadrant, and the second solution that is given by the second quadrant. And this solution in the second quadrant is half a spin minus the reference angle. Half a spin pi minus the reference angle. The reference angle is our first solution. Entonces, we have here, I'm going to start here. So let's start with our second solution. We know that a hard is 2 theta. So 2 theta equals pi minus my reference angle, that is this ugly looking thing, and lastly, my second solution then it's going to be all of this divided over 2 to get rid of the 8 over 56 squared. To get rid of these 2, I'm going to divide everything over 2. So this is my solution, and I'm going to plug this into the calculator. So this is sine inverse of what? 148 times 9.2 over 56 squared pi minus that over 2. So my answer is 1.33. So this is 1.33. And for this thing, I have, again, my hard is actually 2 pi, so 2 theta. So 2 theta is sine inverse of 148 times 9.8 over 56 squared. And if I want to solve for theta, I have to divide everything over 2. So my solution over 2, and this is, let's see if I plug this into the calculator. .24. So these are my possible solutions. Okay, let's see. For this example, I have this function. This function, suppose that the weight above ground of a person sitting on a Ferris wheel is described by the following equation. In this equation, h of t is the height above the ground at a time t. So during the first 5 minutes of the ride, when will the person be 12 meters above the ground? So this is telling me my interval of possible solutions. And this thing is asking me what I need to find. It's asking me a when, so I need a time, and when what? When my equation equals 12 meters. So this is 12 equals 18.7 minus 16.6 cosine of 2 pi over 5t. So if I solve for cosine, this is 12 minus 18.7 over minus 16.6, and this equals cosine of 2 pi 5t. I'm going to plug this into the calculator. So this is 12 minus 18.7 over minus 16.6. This is 0.4036. 0.4036. 36. And if I apply the inverse, first off, starting from here, I can check where my two possible solutions are going to live. This is a cosine that is giving me a positive answer. Because cosine equals x, I know where is cosine positive. Cosine is positive in my first quadrant and in my second quadrant. So these are going to be my two possible solutions. Both of them have the same reference angle, but ojo, I want them both to be positive because I want them to be from 0 to 5, sorry. So my first solution is going to be this one, and my other solution is going to be a full spin minus theta. This is going to be our second solution, okay? So if we apply cosine inverse of 0.4036, this is 2 pi over 6 times t, and we know that we're going to do a substitution of hard equals 2 pi 6t. So this expression can be rewritten as cosine inverse of 0.4036 equals hard. So my first solution is the reference angle given by the calculator, straight up this. And my second solution is going to be a full spin, que es 2 pi, minus the reference angle. Okay? So now that we have here, we have to rechange into our hard. My hard was 2 pi over 6t. So this equals cosine inverse of 0.4036. So if I solve for this t, for my first answer, I'm going to multiply everything for 6 by 6. And then divide everything over 2 pi. So this is my first solution. If I plug this into the calculator, this is gonna be cosine inverse of my answer times what? 6 over 2 pi. This is 1.1. 1.1. So this is my first answer. For my second answer, I'm going to substitute these two values. My hard is 2 pi over 6. Oh my god, in what moment did I change a 5 by a 6? I'm so sorry. This is a 5. 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 So let me change this answer. So let's see, we have this by 5, no, we have this, the inverse of this times 5 over 2 pi, so my actual answer is 0.91, so this is 0.91. So this is a 5 right here. So this answer was 2 pi t equals 2 pi minus cosine of this. And then if I want to solve for t to get my second solution, I have to multiply everything by 5 to get rid of it. And then I have to divide everything over 2 pi. Ojo, this pi and this pi don't cancel each other because they are not factors. So let's plug that into the calculator. So esto 2 so 2 pi minus the cosine inverse that multiplied by 5 and divided over 2 pi gives me 4.08. 4.08. So these are my two possible solutions.